Good morning, Chayton. Fantastic to have you here.
Thanks for having me on today, Frank. Really great to speak with you.
So, can you give me just like a very short bit about what it is that you do with Xilinx, and we'll go into the system on module just after that.
Yeah, no. Thanks for asking. Right. So Xilinx. Whenever people think of Xilinx as an FPGA company. More recently, right, we've transformed ourselves into a system on chip company. But regardless, whether it's FPGA or system on chip, it's a silicon company, right? A semiconductor company. But what Xilinx has done now for many years, over a decade, is we've organized ourselves, into vertical market segments. And so we've got 8 different vertical market segments, things ranging from automotive to wired and wireless communication, data center, aerospace and defense, so on and so forth. My vertical market segment that I'm responsible for at Xilinx is the industrial vision, healthcare, and sciences vertical market segment. We have the distinction of being the largest vertical market segment within Xilinx in terms of number of customers, because there are so many industrial vision, healthcare, and sciences customers out there. So super excited to represent them within the company. And really, our job is to take their inputs in, make sure that our current generation products, meet their needs, but also more importantly, making sure our next generation products, meet their needs, and really the voice of the customer within the halls of Xilinx.
That is an incredible structure, I think, to think about the business actually from the true needs of an end customer. You give me just a quick highlight, like what is, I know, the topic here is the Kria system on module. What is the Kria system on module? And for which customers, which applications would that be really good for? Maybe you can give us a couple examples of how it was deployed within your market segment.
Yeah, and it's probably worth doing upfront as part of responding to that question is level setting on what a system on module is, because one of the things that I've noticed is that as I talk to customers, there's a lot of confusion as to what a system on module is. Because there's so many things out there that are like what a system on module is. There's SBCs, right? So system on modules are SOMs, right? SBCs are single board computers. SIPs are system and package, and there's lots of other things out there that make things confusing. But SOMs, or system on modules, are small embedded boards about the size of a credit card that includes an SoC, system on a chip, such as a microprocessor, a GPU, an FPGA. And then they also have things like memory, power management, and other supporting circuitry. And
Mhm.
so, to get back to your main question, Kria SoMs have Xilinx adaptable SoCs on them, which featuring today with the current Kria system on modules that we have out today are Zinc UltraScale Plus architecture. So that's a little bit about what Kria system on modules are. If we could talk a little bit about maybe what SOMs do and what they're useful for, if you're interested.
Yeah, I was actually thinking, like, what are the advantages specifically around SOMs, but then what are the advantages of using like a Kria, that has the FPGA, on the Xilinx board compared with another board on a processor, like you're saying, or maybe like a system in package or something like that.
Yeah, I mean, well, so let's start with that first, right? So, I mean, what SOMs do, right? So SOMs essentially abstract uh, the hardware, so developers can design at the board level instead of at the chip level. So, hardware designers like tend to really like SOMs because they can avoid like lower value design work, since we've basically the SOM's already got pre-built most of the standard peripherals and connections and stuff like that are already done. Software developers tend to like SOMs because they can start their work in parallel with a hardware team. The common refrain we hear from software developers is, when can I get hardware? When can I get hardware? And it's like, well, if you're designing with SOMs, you're getting hardware from day one, right? And so, and also implied with SOMs is, right, that they're production ready, right? So when you combine, the fact that it saves time for development, but then you also combine the production ready nature of SOMs, it leads to sort of an pretty substantial time to market benefits. But then, you know, we've gone a step further with Kria SOMs, right? Because they can even though they can be used for almost any application, if you look at it purely from a hardware perspective, they were built with specific applications in mind, right?
Mhm.
Spoiler alert, right? Since I'm in charge of industrial vision, healthcare, and sciences, those are the applications that they're really geared toward, right? Vision AI for smart cities, retail, security, healthcare AI, and we've just started to scratch the surface with applications like robotics, industrial communication control, and machine vision, for example. I'll give you just two big advantages of Kria SoMs compared to just a average run-of-the-mill SOM. Number one is in the Xilinx marketing lexicon, right? The Kria SoMs bring the unique benefits of Xilinx adaptive computing to the SOM world, but what does that really mean, right? So when you compare Kria to other SOMs, first of all, there's two other types of SOMs I probably want to highlight. Number one is there are other system on modules out there that are built by third-party developers, like great partners of ours that have basically been out there, repping Xilinx, selling system on modules with Xilinx devices on them for many, many years. So I want to distinguish between them, but then I also want to distinguish between the partners or the class of products out there that are system on modules that don't have any Xilinx devices on there, right? So, if you're talking about advantages of Xilinx over a traditional system on module, then you are asking yourselves, what are the Xilinx advantages over a traditional system on chip or a traditional DSP, a traditional microprocessor, microcontroller type devices? And it comes down to scalable hardware acceleration. With traditional options from great companies out there, right? Companies like TI and NXP, Renesas, NVIDIA, and others, you get fixed hardware, but you have the ability to program purely in the software domain. With Xilinx, and this is sort of unique to Xilinx, you're getting, if I can call it such, like an ambidextrous solution. You're getting the software programmability you get with those other solutions, but you're also getting hardware programmability. So you can adapt to changing standards. You can connect to peripherals that maybe you weren't intending initially to connect to because you've got hardware programmability. You can modify your design to connect to them. You can increase the performance of bottlenecks in your system through the power of hardware acceleration. So you get the best of both worlds. You get that common processor subsystem that people know and love from traditional SOMs, but that enable you to kind of leverage heavy design reuse, but you can also augment the processor subsystem with software callable functions and hardware, aka hardware acceleration, and pick and choose what you want to accelerate. So you get that greater breadth of application that you can use Kria SOMs for compared to traditional solutions.
It's like maybe almost like the Swiss Army knife of of chips, or it actually kind of makes me think even a little bit differently about how, like when I look at, so just this is just a random tangent of my own, but I look at like a Tesla car, right?
Yeah.
So the car is a car, and it's there to drive you, one place to one place. It goes really fast. It's really like sleek looking. They're beautiful cars. Like there's a lot of reasons that a lot of people have Teslas, but it also works as like a backup power bank for your house. And so it's just like a kind of a multi-application, like until you start thinking about your car as like a power system or a battery, that moves, right? It creates a very different, probably a very different approach to some types of development that other folks might get into using a Kria.
Yeah, no, absolutely. I mean, like to your point about sort of like changing the paradigm and changing how people think of things, right? Because Xilinx devices are programmable in nature, both hardware and software programmable, as I just explained. Like it really sort of bends the reality of a developer in terms of what's possible. Like we have this thing that we've had for a number of years called DFX, Dynamic Function Exchange. Because our hardware is programmable, you can time multiplex different algorithms in all the time. So instead of like having one really large chip or one really large SOM that does 10 different functions, you can actually have maybe a smaller, more compact, more power efficient Kria SOM do one function at a time, but constantly time multiplex the other 9 functions in. So you're actually getting the 10 functions, but you're not having to sort of buy the real estate of those 10 functions up front. You can just kind of swap them in and out as you need them. And that to your point exactly, it's one of the cool things about adaptive computing and what Xilinx tries to bring to the embedded design community in general.
That's pretty interesting. So would I use, or like, I'm trying to think like some end applications of the way that operates, right? Like I'm trying to put myself in the shoes of a developer here, and so I'll have probably a couple questions along
Yeah.
that line. One would be, why would I use it? I suppose for FPGA, like use the Kria SoM and the FPGA on the Kria SoM for AI in IoT or like edge machine learning. I know you said you're in the
Yeah.
industrial vision side. Maybe there's something that people are learning within that realm.
Yeah, I mean, I think so in general, right? I mean, people tend to use Xilinx in applications where latency is exceptionally critical,
Mhm.
or there's a higher cost of failure, right? Like in a factory, for example, um, you know, downtime, unexpected downtime, or unplanned downtime is sort of the number one cardinal sin that you just can't have inside of a factory. So you're putting Xilinx components into applications like that, or let's say into an ATM where you're counting money and you want to make sure that someone that asked for 20 euros gets 20 euros and you're not actually accidentally handing out 50 euros, right? Where things absolutely can't fail, right? Those are places where you use Xilinx, and I think that also applies to things like machine learning and things like that, because what's happening is that in general IoT and vision AI systems are becoming extremely like complex and fragmented, and
Mhm.
AI has enabled the capture and correlation of massive amounts of data, and this has led to this like boom in traditional vision systems, but it's also driven new vision use cases altogether. And right now we're probably tracking about 70 different use cases, but that number seems to climb every year. I wouldn't be surprised if we come back and talk again in a couple of years and we're over 100 by then. But I mean, to address the growing number of use cases and expanded functionalities, what we find is a lot of companies out there are trying to deliver point solutions. And they're basically, it's almost like playing whack-a-mole. They're like, oh, we need this over here. And they're building up a solution for this over here. And then, oh, no, we need something, for that over there. And so what ends up happening is that you end up getting a lot of wasted energy, a lot of wasted motion in the engineering process. You get a lot of these custom, oftentimes not scalable algorithms and approaches. And so Kria SoMs let you differentiate, but in a scalable manner, right? Because they were conceived to be used, with real world size, real world power, real world latency constraints. And like I said, I mean, if you want to pick an application, we can pick an application and kind of walk through it. But yeah, I don't know. Hopefully that kind of answers your question.
Well, the application I'd really like is for the Bitcoin ATM or whatever that is in this case, not to be using the Kria SoM, so that I do get maybe I get the lucky lottery.
Well, how about this? Why don't we pick an application like license plate detection in like a smart city, right? So
Okay.
we have an app. And actually, that's something I haven't even mentioned yet. Is one of the cool things that we've done with Kria is it's not just using the hardware and sort of a pat on the back and saying like, okay, you're on your own.
Mhm.
We actually created an app store to go with Kria SoM. So what you kind of the steps to design, and we can go maybe there's more than this, but for the purposes of this case study, right? Typically, the way a user would interact with Kria SoM is, you get the Kria SoM, you go to the app store, you pick the application that most closely matches what you're trying to do.
Mhm.
You download that application, you download it directly onto your Kria SoM. So immediately your Kria SoM is alive and breathing and it's able to do something. Then the question becomes is, okay, how do you customize it for, your specific application? Maybe you're trying to do something unique or proprietary to what your app, your need is, but you've started from a starting point with the App Store, maybe 80% of the way there, and you need to get the other 20% of the way there. But so in
Mhm.
this like license plate detection with Smart City, you can go to that App Store. You could download from one of our partners, a company called Uncanny Vision. You can download their app from the App Store, drop it into your KV260 Vision AI Starter Kit, and immediately you can start detecting license plates. The cool benefit of Kria SoMs is you're going to, with license plate detection, you want to be able to have multiple cameras hooked up to it, right? So you can have, two cameras, three cameras, four cameras, more cameras, the better, right? Get cameras hooked up to it. Kria SoMs enable you to have lower power, higher frames per second than maybe a competing GPU-based license plate detection solution. But all this happens, uh, instantaneously, right? Like you don't need to have a PhD in machine learning or vision AI or any of these things. You can basically start with that, and you can kind of take the iterative tweak approach to building up your design.
Sounds like you're really enabling a lot more applications than and a lot more developers, to speed up the process that may have taken a long time before, or a lot of expertise, or a lot of like very like industry, very specific knowledge that helps them now to kind of bring things up, prove out applications, and get things moving in a pretty sustainable way with that then.
Yeah, no, absolutely. I mean, that's what we're trying to do, right? The analogy I use with Kria SoMs is, and I don't know if you're a coffee drinker, but or if you've ever pulled yourself a shot of espresso, but like you know. FPGA designs are kind of like a very fancy espresso machine where you have all sorts of knobs and dials and things like that, and you can pour you know virtually anything, any sort of style of shot that you want. But sometimes it's more complexity than somebody wants, right? Somebody doesn't want to worry about over extracting and under extracting and all the different, things that you have to worry about with espresso. They just want, a cup of cappuccino, right? And that's kind of what Korea sort of brings to the market. Is it
Mm.
retains the inherent adaptability of Xilinx, and that DNA is still there, but it takes the edge off of it via the App Store and some of the different programming methods that we offer to be
Mm-hmm.
able to allow people, if you don't want the complexity, you don't have to engage with that complexity. But if you want the complexity, you can kind of rip off all the safeguards and you can go straight away and dive right in.
That one hits home a little bit because we're having some issues with the espresso machine here in the in the office this morning. So I'm like having to dial that in. I'm thinking again about grabbing some software and then putting it onto the chip, right? Because that's what we do a lot of this, right? We do a lot of okay, so here's our end application, right? And when we're thinking about design, we're thinking a couple of things. We're thinking longevity, right? How long do you need a product in the market? Like, what does it actually need to do? Make sure you're not, overbearing, have some sort of overbearing solution. Make sure it's lightweight, runs quickly, essentially this. And so, Xilinx and Kria are some of the ways that we get there on a regular basis. But my when I'm thinking about like the software support that you mentioned, is that so? Help me understand what Vitis is. Is that what that is? Is that some kind of library that I'm downloading things from as a developer? And how would something like that help me accelerate my process?
Yeah, it's a great question, right? So Vitis means a lot of different things to different people because precisely it is an umbrella term to represent a unified software platform. So CreaSoms do make use of multiple elements from Vitis, but
Okay.
Vitis includes a whole bunch of different pieces, right? You've got the Vitis high level language compiler that enables you to write code targeted for either ARM processors or for the Xilinx FPGA architecture. Um, it also includes Vitis AI, which lets you optimize. We use a term called pruning your AI models and taking it from like a TensorFlow or Caffe framework and porting it into our hardware. It includes SDKs. It includes hardware accelerated libraries. It includes graphical tools like the Vitis Model Composer and other things, right? So it's a suite of tools that abstract the traditional FPGA design flow and bring Xilinx technology to a user base that wasn't classically trained in traditional FPGA design. And even if they were, right, even if you are a longtime FPGA designer, you may find that you can be more efficient designing at a higher level of abstraction and let the tools do the work for you as opposed to, going all in, right? I mean, there are people out there today that are writing C, C++, Python,
Mhm.
code that could write assembly if they wanted to, right? And there are those of those. I'm not going to raise my hand, and but that have written assembly code themselves, in previous years in their career. But most people don't do that anymore. You don't have to because the tools are so good, and that's also kind of what Vitis represents for us in the context of FPGA design tools.
Boy, those writing some assembly code sounds like a bag of fun. You're exposing me here too when you're talking about the assembly code.
When you got to do it, you got to do it. But if you can avoid it, you certainly want to, right? If you can.
Uh-huh. Yeah, yeah, yeah. Okay, so if I am a developer, okay, and I have never used Xilinx before, but something that we've talked about here has captured my attention. And I say, you know what? I do need to read license plates, or I do have some sort of AI application in the medical space. So what kind of skill set is it that I need to get started? I'm just thinking about myself being a developer, walking into a new project and basically knowing nothing, but saying like, okay, how do I approach this? Do I go on YouTube? Do you guys have libraries of resources? Is it something that should be simple because I already know, I already have a couple coding languages under my belt. Maybe you can help me think that through.
Yeah, it's a great question. So when we envisioned Kria, there's a lot of different things that we envisioned about it that broke away from the traditional Xilinx model. So I think Xilinx is known for having one of the best fleets of field application engineers in the entire semiconductor and technology industry. People have over and over again said, we have the best, the most accommodating, the most bend over backwards for us customers, field application engineers out there. But with Kria, we did not want to necessarily ship every board with a field application engineer because it just doesn't scale very well, right? Kria was intended for non-traditional Xilinx customers. It was intended for customers that we had maybe never met before, right? They probably don't even know who their field application engineer is. So what we really put a lot of attention toward is having the resources available online to be able to get started on your own and to have a very successful engagement on your own. Yeah, there is support, there are forums, there's apps engineers you can call, there is all that stuff, but I think we've done a better job than we've ever done before in
Mhm.
terms of not having you need that. So you're absolutely right. There's a great getting started guide. It's interactive, it's graphical. It lets you branch off to different options. Like for example, if you're using Windows or Linux, it lets you branch off to that. It lets you branch off into if you're using a Yocto-based Linux, or if you're using a Ubuntu Linux, right? It gives you different options, and it helps you get started no matter which path you choose. Almost like one of those old choose your own adventure books. If again, I'm dating myself just like I did with the machine, the assembly code comment here. So yeah, to answer your question, yeah, we do. We have a lot of online resources. We make it super easy. There are of course the obligatory videos on YouTube and everything else. Also, what's become I've noticed pretty interesting with Kria is a lot of the popular embedded personalities on YouTube and other social media platforms have done, their Kria unboxing videos and things like that. So there's a whole fleet of those out there as well. So you can not only see, experience it yourself, you can also kind of learn from some of these other people's experiences.
In your personal opinion, what's the coolest part about a Xilinx Kria SoM? Or
Uh,
like what makes you the most excited about it? I can tell you're very passionate about it, which is incredible, and speaks volumes, I think, to the business itself. Like you can get into a silicon environment where it feels like stuffy, oh, we got to do this or this or this, but what really excites you about it?
well, I mean, I think what excites me is the response that we've gotten from the community and from the industry on Kria SoMs. So literally last week, I heard about a high school student that somehow got a hold of a Kria Vision AI starter kit. And he
Okay.
started doing some experimentation around Vision AI at home. And then he wrote a school report about what he did. And again, he was able to make use of the online tutorials and the documentation and so on and so forth. And it went it was very straightforward for him. So he wrote this paper, and his teacher basically was like, "Hey, this is a great paper. You might want to consider submitting this into something larger than your high school, like IEEE." So next thing we know, IEEE actually publishes this student's paper, and and so it's an official IEEE paper right now, and it's all about Vision AI with Kria. And so to me, like, I think that's the coolest thing about Kria is that um, it reaches a new audience for Xilinx, number one. Number two is like we talked about before, you kind of dial in the right amount of features and complexity for people to work with, and it sort of meets them where they're at, right? If you're AI developer and you don't write any C code, but you're just dealing with AI models, you can play with Kria just at that level. If you're someone that is familiar with writing C and Python code, you can design, with Kria at that level. If you're, a traditional FPGA designer, you can design with Kria at that level. So it kind of meets you where you're at. There's something in it for everyone. And for me, like I say, every week I'm in this sort of enviable position where everyone shares with me all the, the great success stories that they hear out there from the world. That's all the cool things people do with Kria. And to me, it sort of just makes the whole thing, just worthwhile. Like I'm just like so glad that we went down this path. I'm so glad that we've gotten such a great customer response. And but you asked me what the coolest part about it is. It is, hearing these stories right from out there and hearing what people are doing and maybe this kid will be, a like leading scientist in the field of machine learning or AI, based off of this experience he had in high school with Kria.
That's a that's a pretty compelling and very intriguing story. I think the fact that it's so approachable from someone even in high school, and almost like you're saying, kind of like it's like a bring your own mindset, or bring your own tools, or bring your own whatever type of party, right? Like bring it, show up, and see if we can't develop and have some fun here. Wanted to say thanks, sincerely, thank you for joining us, for kind of painting some color around my understanding of Xilinx, first of all, and then also the Kria SoM. I know we've had a bit of an uptick in interest in them recently, and so it's actually quite a pleasure for me to be able to sit here with you and discuss and learn what I can about it.
Yeah, thanks for having me, Frank. It's been a blast talking to you, and yeah, great questions. Definitely some things I didn't think about before, but I really appreciate your interest in Kria SoMs and Xilinx. And we really appreciate a company like Witekio being part of a recent addition to the Kria Design Services Program, right? So you guys are one of our authorized partners for helping customers along on their career journey, right? If it as simple and as straightforward as we've tried to make it, there are always going to be people out there that are doing something that's maybe just outside their comfort zone, right? And so it's great to have a company like Witekio that will help them along in that regard.